Part F.4, find the median of 5-element array. So this question is very challenging. Median of 5-element array. Very challenging. All right? Yeah. You can try if you, but in order to solve it, usually, it may take several hours, but still not easy to get a solution. But actually, if you find the critical part, the insight, then immediately the problem is so easy to solve. All right? Here we have a lot of preparation. If you go through all the examples we have so far at this point, mainly in part E, part F of module 4, then you're pretty much ready to solve this problem. All right, here, let me just give you the solution. All right, okay, go first. Find the median of a 5-element array. All right, so that's simple. First, when n equal to 5 element, we just consider x1, x2, x3, x4, and x5. All right. Median. First thing, we can write it out. At this point, median equals the third smallest element, right? Yeah. Third smallest, the one in the middle. If you sort these 5 elements in ascending order, the one in the middle, that is the third smallest. You can also call it third largest. That is the median. All right. Now the question, the minimum number of comparisons to find the median for the worst case. Yes. Let me emphasize that part. Let me emphasize that part. All right. This goal, we can use another sentence to write it. Use the minimum number of comparisons to find the median for the worst case. How about that? For the worst case. Although you do not see the worst case, right? You do not see this wording, worst case. But based on my description before, in order to solve the whole problem for all the possible cases, you have to overcome the worst case. No other option. You have to overcome the worst case. No other option. All right, so that's it. Now, let me give you the solution using this small space. That's enough. That is enough. Although it is pretty hard, very challenging, but if you get the point, if you get the insight, if you get the critical property, then so easy. A few steps, you'll find the solution. All right, let's start. The first part. Remember the tournament method, right? I mentioned that tournament method before. Let us use that tournament method to organize comparisons. All right. X1, X2, one comparison. X3, X4, one comparison. X5, idle. All right. So the first comparison, second comparison. All right. Assume X1 is the winner for the first comparison. X3 is the winner for the second comparison. All right. After that, let these two players play for the third comparison, and we assume X1 is the winner. All right. After that, let us organize the information we have at this point. All right. Let me draw a diagram for the relationship among all these elements so we can have some visual understanding. First, X1 is higher than X3. Higher here means smaller value. Okay, yeah, because the top one, we mean the smallest element. Yeah. All right. Yeah. This kind of relationship means X1 less than X3, less than X4. All right. Then another one, X2 is here. X2 is less than X1 less than X2 also, all right? Yeah. And X5 is here, but we do not know because we do not have any comparison related to X5. So we don't have any information for X5. All right. Here, there is a critical observation at this point. Critical observation. So let me give you a hint. Here, we need to use the elimination method. Elimination method. That is, which element cannot be the median? All right, let me write the question. Which element cannot be the median? Yeah, based on the information we have at this point, cannot be the median. Should be eliminated, right? If an element cannot be the median, should be eliminated. Because after the elimination, we can simplify the situation. All right. Now, if you look at this diagram closely in a few minutes, I believe you will get the answer. Only one element. It has no chance to be the median. Median means the third smallest, right? Third smallest must be third smallest. Then that means there are two elements with smaller value than this one. With that criteria, all right, is X1 can be the median? X1 is greater than X2, X3, X4. X1 less than or greater than X5, it is unknown. There is a possibility X1 less than X5 or X1 greater than X5. Either case is possible, yeah. But in both cases, X1 cannot be the median. All right. So we have the conclusion, X1 cannot be the median. Now, after three comparisons, we get our first result. X1 cannot be the median. So X1 can be eliminated from the consideration. All right? Yeah. We do not need to consider X1 anymore. if we want to find the median of 5 elements, right? So after x1 is eliminated, then what do we have remaining? We have x3, x4, we have x2, and x5. All right, yeah, remaining 4 elements. Now we need to update information. After x1 is eliminated, the original median, so here, the original median, all right, yeah, original median equal current second smallest, right? You take away x1 could be the first or second smallest, but you take away that one, all right? Then the second current smallest is the original median, right? So now find the second smallest. We just learned how to find the second smallest, right? But when you find the second smallest, you can use this result because we know x3 already less than x4. You do not need to do another comparison between x3 and 4. So you do one comparison between 2 and 5. No matter it is which one is larger, we can assume x2 is smaller, all right? Yeah. Then x3 and x5, x2, so that is second let me just write continuation of the comparison. How about that? So comparison number 4 between x2 and x5. Comparison number 5 between x2 and x3. Yeah. Let us assume x3 is the winner, that means smaller than x2. Then the last comparison. Remember, the direct losers to the winner is x3. Direct loser only x4 and x2. All right. So the last comparison between x4 and x2, the winner, this winner will be current second smallest and the original median. How about that? All right. And then this should be the comparison number 6. All right. So the answer, the final answer, the number of comparison to find the median of 5 elements, 6 comparisons. Yeah. That's just number, but the solution, we can use this diagram to represent. Elimination method. Eliminate that one element that has no chance to be the median. After that elimination, you only need to find the second smallest element in that 4-element array, remaining 4-element array. But when you find the second smallest in 4-element array, there is one comparison. You do not need to redo it because you have the result. Why you redo it? Do not need to redo it. So you can use that comparison result so you can save one comparison. After that save, you just need 3 more comparisons to get the second smallest. 3 more new comparisons plus 3 old comparisons. 3 plus 3, total 6 comparisons. All right, so that is the solution. Try your best to understand this problem, the solution of this problem. Yeah. All right, so then probably I may give you some questions related to this solution. Yeah. All right, so let me stop the last video of part F.